Today's lesson is going to be a short video because it's the process that we used yesterday that we're using today. Everything's identical to our last video of solving trig equations. The only thing is today you can use a calculator. So when I see this example here and I see that I have 3 theta, I want to keep in mind that it's easier to call this alpha for a little bit and solve. And it's also easier now to think of my alpha from 0 to 540 degrees. And the 540 came from 180 times 3 because of this 3 theta. Because I need to be sure that I capture all of the solutions that work within this domain. So in order to figure out alpha, I take the inverse of 5/7. Now remember, we need to use our CAS principle and our related acute angle. So cos is negative in that quadrant and that quadrant in there. So when you use your calculator and you use your inverse function, you get 44.4 degrees for your related acute angle. Those 2 angles in there. So what the angles actually are is 135.8. 135.8, so that's how much this terminal arm moved. And then this angle in there is 224.4. Now keep in mind, we want to be sure that we capture all of the angles, so we need to go up into 540 degrees. So if I move my first arm, this arm here, the degrees it already went, the 135.8, and then I take it in another full circle, which just means I'm adding 360 degrees to it, I have 495.8, and that's still less than 540, so I'm still within my domain. If I do the same thing to that second arm, I swing it all the way around 360 degrees, it goes 584.4 degrees. Now I see that I don't need this one because it's greater than 540 degrees. It's always sort of nice to go that far so that you see that you've captured them all. Now we need to remember that we're not dealing with alpha, we're dealing with 3 theta. So we have to bring that back in to solve for all of these. 3 theta, do a little bit of algebra, and then we have all of our solutions for theta. I'm just going to move my alpha down a little bit, that 495.8, so that I have room. So alpha equals 495.8, and we bring the 3 theta back in for that as well. So we bring in 3 theta, 3 theta there for the 495.8. So now if you divide all of these by 3, your first solution is here is 45.3 degrees. Divide by 3. Theta is 165.3. And my last one here, if you divide them by 3, theta would equal 74.8 degrees. So our 3 solutions for this question is the 45.3, the 165.3, and 74.8. Keep in mind what that means is if you substitute any of these angles into this equation, your left side would equal your right side. That's the whole purpose of solving equations. So we'll do one more example together, and then that's it for today's lesson. So our next example here is tan theta plus 90 degrees equals 5. So because there's nothing multiplied by our theta, we don't need to change our domain at all. We just need to keep in mind we're looking for all the solutions between 0 and 180 degrees. So that I don't have to worry about the theta plus 90 right away, I'm going to make that alpha, all of it. Then I do the inverse to the ratio of 5, and my degrees there gives me 78.7 degrees. What I then need to keep in mind, excuse me, just check up here what I meant to write here. The original question was theta minus 90 degrees. So we have to keep in mind that our alpha is actually theta minus 90 degrees equals 78.7. And then we have to solve for theta. So what we have is 78.7 plus 90. So theta equals 169.7 degrees. That's the only solution that fits between 0 and 180 degrees. So that's the final answer there. Highlight that, like we did in the others. So that's it for how to solve equations with a calculator. What I'd like you to do is try our last equation and bring it into class with you tomorrow. Keep in mind for this one you can use your calculator. And be sure to show all of your steps, remembering your cast principle and your related acute angles.